question number 3b, it says that it's known for some y equals cx equals or cx root 4 minus x squared, the derivative is equal to this expression given here. And for a particular spinning toy, the radius of the cross-sectional circular slice is 1.2 inches. So the radius here of this cross-sectional slice is going to be 1.2 inches. So that's what it's telling us here. And what is the value of c for this spinning toy? Well, I first of all need to figure out where is it going to be the maximum. I need to know where this x is. Okay? And once I know where this x is, I can then calculate the position by using this expression here. I can calculate the radius of that spin here, which is the height of this graph at that point. So first thing is I have to figure out the position of x, and I'm going to use a derivative to find that, because I know that the derivative here is going to be a horizontal tangent, or y prime equals 0. Okay, so then I have my y prime, so I know that dy by dx is equal to 0 where I'm looking for, and my equation is going to be this, c 4 minus 2x squared over square root of 4 minus x squared. Now I do have to solve this as an equation for x, and that will give me the positioning. But I don't need to worry about this denominator, other than I should really make sure I state that there are restrictions. X cannot equal plus minus 2. And then once I've established a restriction, I can just get rid of the denominator and just solve for that. So then I end up with 0 equals c 4 minus 2x squared. The c is not going to affect the solution. Okay, I can factor this, so I can end up with 2c equals 2 minus x squared. Okay, when I solve this equation for x, I get x is equal to plus minus square root 2. Okay, so I can just undo the minus, and I can undo the square with this square root. Now we know that looking at this picture, we can assume that this is going to be square root 2. Okay, so that's the first part. That's part 1. The second part really is I need to solve for the value of c. So I need to know what my vertical expansion of this original function is here to be able to get a maximum height of 1.2. So I'm going to set it up this way. So this is the second part of the problem. I know that the y value is equal to 1.2, and I know what happens at an x coordinate of square root 2. But what I don't know is the c value. So then I just need to plug in the x value into this equation. So I end up with 1.2 is equal to c root 2 times square root of 4 minus root 2 squared, which is going to be 2. So I get 1.2 is equal to c square root 2. This becomes 4 minus square root 2 squared, which is 2. And so I get 2c is equal to 1.2. The c value then works out to be 0.6. Okay, so the value of c for this spinning toy, which gives me a cross-sectional radius of 1.2, the c value is going to be 0.6. Okay, so this is a c value.